this is Operation. When you hit the sides, you have a little LED that lights up and a buzzer that goes off. The goal of the game is to extract the pieces from the inside of the body cavities, like so. We have weight sensors, pressure sensors underneath each of the body cavities to tell when you've removed the pieces. Those readings go over to our IoT on ThinkSpeak.
And we also have a printout of the readings on the serial monitor, so when we were building the circuit, we would be able to test, like so. So you can see the different values, 0 when obviously nothing is touching the sensor versus higher values when something is pressing on the pressure sensor. So in terms of the subcomponents, we have a laser cut game board, which you can see has the etching of the man on the game board in the real game. So that lies on top of the circuitry. They're all wrapped, the body cavities, in tin foil. So we're using conductivity as a sort of metric for setting off the buzzer and the LED. So then the board just rests on top of everything else. This is the circuitry that we have on the bottom. So you can see the different components for the force sensors and then the wiring for the LED and the buzzer up near the top. So basically the different regions of the circuit correspond to the different regions on the game board that they represent. And then of course on the back there's tinfoil running all the way across to connect the different regions of the body cavities, just so you would have a full conductivity. And then of course we have the tweezers that we're using to actually fish the items out of the holes. So that is just wiring attached to a metal pair of tweezers that we got and brought in. And then this top is made of shrink tubing that we used with a heat gun just to secure the wires on top. And then of course here is the UNO Wi-Fi. So in terms of improvements that could be made, we found that because the board just wraps on top of the circuitry, whenever we put it away and took it back out, we would have to debug the circuit as things usually popped out or got displaced. So that was one of the challenges. So if we could go back and spend some more time on this, we would obviously make it a little bit more portable. That would mainly include making more of a box as opposed to just the sheet lying on top of the rest of the circuit. However, we printed this out of scrap material, so we didn't really have a whole lot to work with in the end. And then just continuing to reinforce. This worked out pretty well. We used double-sided tape, but there probably would be more sturdy ways to manufacture, maybe using like wire or just harder metal material.
And then also, there are some problems getting the wires to connect to the top of these tweezers, and still sometimes you need to squeeze them down in order to make the circuit complete. So figuring out a more efficient way to keep the wires in connection with the metal would also be an improvement for another project.
So that's it for Arduino Operation.
Yeah.